Hello friends, in this video I am going to explain you the concept of transfer function used in control systems. In the video, first I will give you mathematical equation of transfer function and terms related to it. Then theoretical information, then elements of transfer function, their time domain specifications and Laplace form. After that, we will see an example to understand the procedure to determine transfer function. Let's start with the mathematical form of the transfer function, and it is given as transfer function is equal to Laplace of output upon Laplace of input. To understand the terms related to it, let's assume transfer function is equal to k into s plus 10 upon s into bracket s plus 1 into bracket s plus 2. Here k is equal to gain factor, that is, it gives stability of the function, gives stability of function. Here also pole is obtained by equating the denominator to 0, that is roots by equating denominator to 0, that is here s into bracket s plus 1 into bracket s plus 2 is equal to 0. So pole is equal to, in this case, s is equal to 0, s plus 1 is equal to 0, s plus 2 is equal to 0. Here therefore pole is equal to 0 minus 1 minus 2 in this case, and next is 0. 0 is obtained by equating the numerator to 0. Here 0 means roots by equating numerator to 0. Therefore here s plus 10 is equal to 0, that is 0 is equal to minus 10 in this case. Here this equation is known as characteristic equation. Characteristic equation. Let's see the definition of transfer function. In any system, first the system parameters are designed and their values are selected as per the requirement. Input is selected to see the performance of the system design, that is output. Here input system parameter gives output. Output is equal to effect of system parameters into input. This effect of system parameters can be expressed as output upon input, that is here effect of system parameters is equal to output upon input. Transfer function can be transfer function is the Laplace of unit response of the system, that is here transfer function is equal to Laplace of unit response of the system. The theoretical definition of transfer function is a function explaining the effect of system parameters on input to reduce the output is termed as a transfer function. Now let's see the elements of transfer function, their time domain specification and Laplace form. First element is resistor. There is its time domain specification is r small I of t and Laplace form is r capital I of s. Second is inductor denoted by L. Its time domain specification is L into di upon t dt and its Laplace form is s L I of s. Third is capacitor. It is denoted by C. Its time domain specification is 1 upon C integration of I dt and its Laplace form is 1 upon SC into I of S. Fourth is current. It is denoted as I. Its time domain specification is I of t and Laplace form is capital I of s. Fifth is input voltage. It is denoted by V of I. Its time domain specification is Vi of t and Laplace form is Vi of s. Sixth is output voltage. It is denoted as VO. Its time domain specification is VO of t and Laplace form is VO of s. Now let's see an example to understand the procedure to find out the transfer function. This is an example. We have to find a transfer function. Here this is the resistor, this is the input voltage, this is the output voltage, this is the capacitor and this is the input current. This is input side and this is output side. Now let's start to solve the question. First, input and output variance in time domain specification we need to find. So input and output variance in time domain specification. Here first we will find input variant V of I, Vi of t is equal to, here first is the resistor, so Ri of t plus then capacitor 1 upon C integration of I dt. This is our first equation. Second is for output variant Vo of t is equal to, here only capacitor is present, so 1 upon C integration of I dt. Here there is nothing in this side, so only capacitor we have taken. So next is Laplace of this input and output variants. So Laplace of input and output variance. Therefore, VO of S is equal to 1 upon SC I of S. So VO of S into SC is equal to I of S. This is our second equation, this is third equation, this is fourth equation. Now for input variant, Vi of S is equal to R capital I of S plus 1 upon SC I of S. This is equation number 5. Now substitute the equation 4 in equation 5. So substitute equation 4 in equation 5. Therefore, we will get Vi of S is equal to R into VO of S into SC plus 1 upon SC into VO of S into SC. Therefore, Vi of S is equal to R VO of S into SC plus SC gets cancelled, so VO of S. Therefore, now VO of S is a common factor here, therefore SCR plus 1. Therefore, now here Vi of S upon VO of S is equal to SCR plus 1, and transfer function is equal to VO of S upon Vi of S, that is here 1 upon SCR plus 1. This is our transfer function. Friends, please like and share this video and subscribe my channel. Thank you.